Okay, thank you very much for joining. So today we're starting a new unit, which is programming and scripting. So from our unit aim, we will now focus on principle of programming and scripting using Python programming language. So with Python, we're going to look into the general, which is a general purpose language that is used for a wide range of context. So this is a very worldwide and useful language. So it can be used across to create different applications, and is used. We will use it. We will look into which sectors are using this, such as web application and bespoke application. And in today's session, we're going to understand the principles of computer programming. So we will give an introduction to computer programming in general and its use. And we'll look into our 3 learning outcomes, where we're going to explain the key programming paradigms, explain languages, constructs to be used within the program, with an emphasis of Python programming language. Then we're going to explain the key difference between programming and scripting with examples. So let's dive into our presentation. So we have introduced our unit aim, and obviously this is a level 4 qualification. So what we'll do, we'll look into the fundamentals. We need to understand what is the reason behind programming language, and we'll look into explain some of them. So we all know that computer programming is simply the process of designing and building executable computer programs to accomplish specific tasks. So whenever we creating a program, we're coding, we will now looking into creating, for instance, object by declaring our functions and making them do certain commands. But it's also really important to looking into the data structure. So why is data structure important? This is a way to organize and store data so it can be accessed and modified effectively. So by having data structure, we're now going to reduce the time complexity. So we're now going to save on space and time. So we're going to create readable and executable code. So there are different type of data structures, which are arrays, linked list, queues, stack, trees, maps, graphs, and so on. So depending on what sort of program we're going to create, we will now look into which data structure we will now require to use to make our code readable, and it takes the less memory and time to compile. So algorithms are step-by-step procedure to formulate and solving these problems. So this key concept also involves control structure, where with sequence, we're going to look into the execution of statement, one line after the other. Selection, we're going to be able to make decisions. For instance, we'll be using if statement. Iteration, where we're going to be repeating sets of commands with our loops or do-while loops. Modularity and functionality. So with modularity, we're going to be dividing a program into separate modules that can be developed and tested independently. And functions, So with functions, we're going now to build a block of code which are going to be designed to perform specific tasks. And also they can now be reused themselves again. Abstraction, we're going to simplify the complex system by modeling classes appropriate to the problems. So we're going to use a very important functionality with abstraction, error handling as well. This technique helps us to undo errors and exceptions when they're thrown to ensure that our program can cope with unexpected situation. And also we have code readability and maintainability. So we have to, depending on whoever is going to work on this code, if we're working independently or in a team, we have to be able to write code that it's easy to read for other developers and can be also easy for them to maintain or improve. So looking at Python, so we'll now introduce Python, which is a high-level programming language. So what do we mean by high-level programming language? We're simply looking into programs that, like JavaScript, that they use an interpreter rather than a compiler. So computer programming like Java, C#, they work with a compiler. So basically, we now give a command. Our compiler will now convert into binary numbers, and you now give us an output, while with the programming language such as Python and JavaScript, they work with an interpreter. So basically what the programming does, he try to understand and interpret what we declare into them. So here we can see that these are simply unreadable. So the syntax with Python is less. You have to give less commands compared to a programming language like Java, which requires a compiler. So Python syntax is clear and readable, which make it easier to write and understand. It's dynamic. So variables in Python do not need explicit declaration before the use, which allows it to be very flexible code. As mentioned, this is an interpreted language where Python is interpreted, meaning that the code is executed line by line, which makes debugging easier. Extensive standard library. So we all know, as we all know, Python has a various number of library such as NumPy and Minion, which can be used for web application or used for machine learning. Also, is object oriented. So this is useful when it comes to like building software. So when it comes to creating web application, we can now work with object. So let's look into the type of application which we can find Python. So this is a versatile, Python is versatile, and it allows us to use it across various fields: web development, data analysis and machine learning, scripting automation, game development, DevOps, and system administration. So Python is very in high demand. Developers who have the ability to code with Python have a very high chance to secure a job within any of these sectors, IT sectors. So now we're going to explain the key programming paradigms. So what are these key programming paradigms. So we're just going to look into distinct approaches to programming based on certain principle and methodology. So these paradigms help us understanding the essential for developing effective and efficient and effective softwares. So we're now going to look into each of them, and these are procedural programming, modular programming, functional programming, and object-oriented programming. So with procedural programming, this comes from structured programming, and we basically emphasize the use of procedures or routines to perform computation, where these paradigms is based on a concept of procedure call and is structured around idea of sequence of statement that can manipulate data. So what are the key characteristics? It has a linear execution where programs are composed on a sequence of instruction. Procedure and functions, where modular units of code can perform specific tasks. Global and local variables, so we can store variables that can be declared globally or even locally within our function. Control structure, which is we can now also use loops and conditionals to create our iterations. And here we have a clear example of declaring our variables, and will now be returned with a value. Modular programming. This focuses on dividing a program into separate self-contained modules. Each of them are going to represent a specific aspect of our program's functionality, and they can all be developed, tested, and maintained independently. So what are these characteristics for modular programming? We're going to look into separation of concern. So we're going to divide programs into distinct modules with specific responsibility. Encapsulation. So with encapsulation, each module is going to hide its internal implementation and expose only what is necessary. Reusability. Modules can now be reused across our program or different projects. And it can also be maintainable, which is easy to maintain and update. Here we have an example for our modular program, where we now again declaring our variables and it is returning a value to us. Functional programming. This now treats computation as the evolution of a mathematical function and is also going to avoid changing state or mutable data. So why does he emphasize the use of functions, immutability, and declarative programming? What are the main key characteristics? He has first-class functions, which these are treated as first-class citizen, meaning that they can be passed as argument. They will now return, they will also be returned from other functions. And also they're going to be assigned to our variables. Immutable, so this means that the data is immutable and it cannot be modified across our programs or project. Pure functions, where functions have no side effect and return the same result given as the argument, and high order functions, where functions can take other functions as argument to return them as results. Here we have example for it. Now we're looking into, I think, the most common and used of them, which is object-oriented programming, where programs here are now based on concept of object, which are instance of classes. So we'll now be working with classes. Object-oriented programming focuses on encapsulating data and behavior into object and defining the relationship between these objects. So what are the key characteristics? It works with classes and object. Encapsulation, where we're going to build data which are our attributes. So for some programming language, such as Java, these are called methods, while in Python, we call them functions that can operate on the data into single unit. Inheritance, so it's going to create a new classes from existing classes. So we're going to inherit the code. Polymorphism, which is the ability to redefine methods in other classes, allowing for different implementation. And lastly, we have abstraction, where we're going to hide the complex implementation details and exposing only our necessary interfaces. So here we have an example where we are creating our class, where we have our parameters, which have been set, and we have it's pretty much covering all the key concept, where we're going to use abstraction, inheritance, and rest of them. So to conclude this learning outcome, each programming paradigm offers a unique approach to solving problem and writing software. So procedural programming focuses on linear sequences and functions code. Modular program on separation and encapsulation of constant. Functional programming on immutability and mathematical function. And object-oriented programming focuses on encapsulation of data, where we're now going to be working with objects. So now we're going to give an introduction to how we're going to explain how this programming language will now construct a program. So how to construct with Python is the fundamental building block used to create a program. So construct enabled the writing of efficient and readable code. And now we're going to explain the key concept. So when we have to declare a variable, we have to, for instance, we're trying to do a mathematical calculation where we're going to assign values. We're going to store values into our variable. So we can look at variable as boxes where we're going to store a value, which is our data, and it can be manipulated and referenced throughout the program. So variables are dynamically typed, meaning that this type is determined and at runtime and can change. So variable is the opposite of constant. So when we declare constant, this is a fixed value which cannot be changed within our code. So for example, here we could declare a string, which is a type of variable, but it goes with characters. We could declare integer number with our variable, which we name as x, and the value, the data that we're going to store into our variable is an integer, which is the number 10. So these are called data types. So there are different types of data types. We have double, integer, Boolean, which is going to check if a statement is true or false. Then we have double, which is numbers with more digits, so with decimal digit. So if we need to make a receipt from a shopping list where we're going to return a change, we'll now use a double because we can return an integer because it is a decimal value. Also, constant, a variable, as I explained, which do not change. So for instance, pi, numpy, it is a fixed value and cannot be changed. So when we trying to calculate, doing a mathematical calculation, we know that this value does not change. Also, we have operators, which we all know most of them. We all know all of them. We have arithmetical operators, comparison, logical operators, and or not, assignment operators, and so on. Sequence, which refers to execution of statement in a specific order, one after the other. And these are default mode of execution in Python. Selection, well, with the selection construct, will now allow us to program to choose different paths of execution based on conditions. Iteration, as mentioned before, we're now going to recall the same mathematical calculation, but we're going to execute this with a block of code, and this can be done with loops iteration. Also, we mentioned Python has a various number of library depending on which sector we work in. If we're working in machine learning, we'll be using loads of them. So matplot library is used for data visualization. NumPy is used for numerical computation. Pandas is very used in data visualization and data manipulation and analysis, and so on. Also, we explain that when it comes to creating objects, we have to build them with functions. So Python provides many built-in functions that perform common tasks. These will now include functions for data type conversion, mathematical operation, input and output operations. We also have user-defined functions, where with user-defined function, these are created by programmer to perform specific tasks. And these functions are going to enhance our code reusability and modularity. Now we're going to explain the key difference between programming and scripting with example. So as our definition says, the difference between programming and scripting is that programming and scripting are two concepts in software development that often overlap, but they have distinct characteristics and typical uses. So to clearly understand the difference, it is useful to compare them in structured manner and explore typical uses of scripting. So we have a definition for both of them. Programming is writing code to create applications that perform a wide range of tasks, while a definition for scripting is writing code to automate tasks and manipulate existing systems. So there are different types of execution for them. So programming will now look into having a compiler, as I explained. So we now have a compiler that's going to convert our English language into binary number, which is what our machine understands. And scripting, such as Python and JavaScript, is going to use an interpreter. So what is the scope? Typically, programming is used for large-scale software development, while scripting is used for smaller tasks and automation. So they both have speed difference, where programming is faster due to compilation, and scripting is slower due to interpretation. While when it comes to development time, programming will now have a longer development time due to the complexity, while scripting will have a shorter development time, which is quicker to write and test. When it comes to flexibility, they are less flexible and more rigid in structure, while scripting is more flexible and easily changeable. So we've given an example of programming languages that use compiler and or the programming that use interpreters, and they very much shows what is the difference between a low-level language and a high-level programming language. So typical use is pretty much when it comes to programming is used by full stack developers, while scripting might be used for front-end developers or other sort of jobs. So here we can look into typical uses of scripting. So Python are often employed in various contexts to automate and simplify tasks. So they're very useful when it comes to extracting data from data set. So scripting can be written to extract, clean, and process data from large data set. That's why Python can be used to read a CSV file, filter data, or output the results. Data pipeline, as mentioned also, Python can be very useful when it comes to front-end development. So scripting languages like Python are used for server-side scripting to handle web requests and interact with databases. Task automation, where scripting are used to automate repetitive tasks such as file management, system monitoring, and batch processing. So to conclude this session, the key difference between programming and scripting will now lie on the execution, scope, and speed, development time, flexibility, and typical uses. So why programming languages are often associated with development of large-scale application and system software. Scripting is more focused on automating tasks, handling data pipe, web development, and extract data from data sets. So we're now looking into data analysis and machine learning. So scripting languages like Python provide powerful tools for quickly writing and executing code to perform a wide range of automation tasks. So this was everything for today's session. Is there any question for me?
Hi, thanks, Victor. So no, I don't think so. I think once we start getting on to like the actual coding elements, and I think there's definitely going to be some more questions there. I did a Python boot camp probably about just over a year and a half ago now with Bridgewater and Taunton College. So I've got a fairly good understanding of what I say. I've got a understanding of like Python coding and using it as sort of like a very like basic level. It's something I'm very interested of implementing in my work in data analysis because make my my life a lot easier if I could you know, get some programs to, you know, maybe do some of the data cleaning and stuff for me. So yeah, something I'm aware of, something I've got a little bit of skill in, but I think when it comes to the actual like writing the code and doing that sort of thing, that's definitely when the questions start coming for me. But no, for today that was all very clear. Thank you.
Okay, I understand more. Yeah, so if there's no any other question, I'll just end this session. And I'll see you tomorrow.
I'll catch you tomorrow, Victor.
Okay.
Have a good evening. Take care. Bye-bye.
You too. Bye-bye.